In this question, we've been asked to expand two expressions. Our first example, x plus 3 times by 2x minus 7, contains two brackets. We can expand this expression by using various methods. The first method we'll look at is called the FOIL method or smiley face method. We take our equation and we multiply the x by the 2x to give us 2x squared. That is, we multiply the first terms of each bracket. First gives us the f in FOIL. We then multiply x by minus 7 to give us minus 7x. We've multiplied the outsides here, so that's the o in FOIL. Next we take the 3 by 2x, and that gives us 6x. The insides in FOIL. And finally, we multiply 3 by minus 7, the last numbers in each set of brackets, the L in FOIL, and that gives us minus 21. We could leave our answer as it is, but there are two x terms, minus 7x plus 6x. We can combine these together by performing the calculation, and this gives us 2x squared minus x minus 21. Now that's method 1. Method 2 is the grid method. We draw a grid with a times sign. We take our first bracket, x plus 3, and add it to the top of our grid. We then take the second bracket, 2x minus 7, write the 2x in the first position and the minus 7 in the second position. And then we multiply out as we would normally in a multiplication grid. So 2x times x is 2x squared, 2x multiplied by plus 3 is 6x, minus 7 multiplied by x gives minus 7x, and finally minus 7 times plus 3 gives us negative 21. We then write out our answer. 2x squared plus 6x minus 7x minus 21. As above, we combine together our like terms, which gives us 2x squared minus x minus 21, and that's the answer we've got using the FOIL method. Our second example is y plus 3 all squared. This is what we call a perfect square. That's because, if we think of an area, one side would be y plus 3 and the other side would also be y plus 3, the area of a square. We can expand by saying that y plus 3 all squared is equal to y plus 3 times by y plus 3. Again, we can use the FOIL method to expand our brackets. We multiply the first terms, y times y, and that gives us y squared. Next we take the outsides, y and 3, multiplied together gives us 3y. Then the insides, so that's 3 and y, and that gives us 3y. And finally, the last numbers, 3 and 3. Multiplied together, that gives us 9. So that's y squared plus 3y plus 3y plus 9. We can simplify by combining the like terms. 3y plus 3y is 6y, so our answer is y squared plus 6y plus 9. We can also use the grid method. First we draw our grid, then we write the first half of our expanded term across the top, y plus 3, and we add our second term, y plus 3. We then multiply out. Y times y is y squared, y times 3 is 3y, 3 times y is also 3y, and 3 times 3 is 9. We write out our answers in a line, y squared plus 3y plus 3y plus 9. Again, we can simplify by adding the like terms, 3y and 3y. And that gives us y squared plus 6y plus 9. If we look at our answer, we can see a pattern. Look at the y in our original equation, and we have y squared. We had 3 in our original equation, and we have 9 in our answer. If we square the 3, we get 9. If we square the y, we get y squared. But what about the 6y term? How can we get that using the y and the 3? Well, if we times the y by the 3, we get 3y, and then we double that to get 6y. So more generally, If we have x plus a all squared, square the first term, that's x squared, square the last term, that gives us a squared, and then for the middle term, it's twice the product. The product is ax, so that's 2ax. Similarly, if we have x minus a all squared, square the first term, x squared, square the last term, minus a times minus a still gives us plus a squared, and then twice the product. The product is minus ax, so that's minus 2ax. Knowing these expansions can be very useful.